Yesterday we stopped here, and this is the interesting part. We're actually going to see a little small demo, and I actually forgot to go grab the thing out of the back. So I'm going to pause this in a minute and go grab it out of the back because I think it's important that you guys see this. And it has to do with electrolytes versus non-electrolytes. And before I start this, does anyone have any juice, like any flavored drinks with them? Okay, if you do, just get it out. I don't care. I'm not going to steal a whole lot. Now, water, it doesn't matter. I don't want water. Yeah, that's okay if you didn't. Normally someone has a Gatorade whenever I do this, but that's fine. What is that? Okay, that's good. We can do that. All right. So electrolytes versus non-electrolytes. The first thing that I want you to write up here at the top, and you can write it above it, is, and I'm going to write it right here. I want you to write it up here at the top. Okay? Must have, and again, I'm writing it, no space available. And there is an S on this, and this finishes an N. So electrolytes versus non-electrolytes. The key that you're looking for are ions in solution. Okay. You have to have ions in solution. So right here, we see this cool little setup where it has a light bulb. Ooh, fancy. Okay, and it's got these wires running. And it's got these wires running. It's got these little alligator clippy things. And then there's a piece of graphite. And it's stuck down in pure water. Okay. Now, what do we know? Because graphite is a conductor of electricity. They could have used any metal. Yeah, they could have used copper. Okay. So what we've done is we put an electric current in this water. And we're seeing if the water will conduct it. Because here's the thing, sir. I didn't give you one yesterday. Actually, you're going to get one out of the trash. It's clean. It's brand new. Because I had too many of them to do some one. So here's the deal. If I take these two prongs that are sitting right here, and I make them touch, okay, even outside the water. If I was holding them in my hands right now and I made them touch, should the light bulb light up? Yes, okay. So what we've done is we've essentially cut the break, or the line. We've cut the connection between the wires, okay? And what we're trying to do is we're trying to see if this is a power source, okay? What do we have to have for this light bulb to work? And it's just a basic, simple answer. Give me the basic, simple answer. We've got to have electricity. So a power source is essentially electricity. Now, we know that electricity is what? The flow of electrons. So what we're essentially trying to do is seeing if we can get the electrons that are running around in that solution to run through the wires. Because if they run through the wires, will it turn that light bulb on? Yes, ma'am. Power source. My apologies. I know that as soon as I wrote it, it didn't show up real well. So we're trying to find a power source that will light these two things up, okay? Because once you break the circuit, there's not a power source anymore. So we're going to see if that water will do it. Now, according to that light bulb, is water, pure water, a power source? No. It will not conduct electricity. There are no electrons, okay? Well, let's look at sucrose. Now, what is sucrose? It's sugar, okay? Essentially, it's table sugar. And I know you can barely see that, but that says table sugar. Okay, so you guys have all been to Waffle House. Imagine that big thing of sugar on the table that you can just kind of dump in. So if you did that, it will not work. What'd you just say? Like, you have been deprived as a child. Like, that's torture. No. Whoa. So here's the deal. Now if you look at that last one, what did they pour in there? Sodium chloride. And notice what miraculously happens to It turns on. So here's the concept that I'm trying to get you to understand. If we have water and we dump in an NaCl solid crystal, I told you to write down at the very top, for this to conduct electric current, what must be floating around? It's got to have ions. This is an ionic bond. So there's two questions I must ask you. Number one, if this thing were to turn into its ions, what would it be? The sodium ion and the chloride ion, so Na plus and Cl minus. Now, because this solution, and I'm going to excuse my drawing here. Okay, because this solution magically produces light, okay, what does that tell me about this solution? It has ions in solution. Okay? Because of those ions, it will allow it to conduct some sort of electricity. That is light, yes. Okay? It is lit. It's so lit. Well, too bad. It wasn't funny because you said it. Now, it was a debacle. My second question to you is, this is another way to test this word right here. If we want to know if a solution is soluble or not, or the solubility of a solution, we can determine that through conductivity. Now, what is conductivity? How good it conducts electricity, right? So we can take a bunch of different solids and we can pour them in water, and we can determine, like, do you agree that, like, it's essentially, instead of having a light bulb, we can have something called a voltmeter, and it's going to give us a number here in volts? Could we, instead of a light bulb, could we have that, and that would tell you the amount of current running through, the number of voltage, right? Does that make sense? So that's what we would do to compare the conductivities of different solutions. And I'll go ahead and tell you, and there is an R on this. This thing right here is very important to electrochem. We're going to be talking a lot about a voltmeter. Okay, so in terms of us being able to figure out what solution conducts the current the best, we would need to use a voltmeter. A light bulb, obviously, you could see the visual differences because it would be dimmer or brighter, but the voltmeter would give you an actual quantitative piece of information, not qualitative, not a description. Okay, but that's what we could use to determine solubility as well. Because, and the reason I'm referring to this is because the more ions you have, what would that tell you about the brightness of the bulb or the amount of voltage? The brighter and the higher the voltage. So the more the compound is soluble, would you agree there are more or less ions in solution? More ions. Well, the more ions you have, the more conductivity it would also have, right? Well, the more conductivity it has, the more soluble that substance is. So it's kind of like a circle. Does that make sense? So if it's soluble, it has ions, therefore it'll conduct electricity, therefore it's soluble. So it kind of just connects like a circle. Does this make sense? So here's what I'm going to do. I'm going to go let me go back and read, make sure to miss anything. If the amp or voltmeter measures a current and the bulb glows, then the solution conducts electricity. If the ammeter fails to measure a current and the bulb does not glow, the solution is non-conducting. Okay? So here's what an electrolyte is. An electrolyte is a substance whose aqueous solution conducts an electric current. If you like to highlight stuff or star stuff, this second bullet is the long definition of why it's an electrolyte. The more mobile. What does mobile mean? Move and charged particles. Let's actually go back to mobile. If a solid is if a compound is in its ionic solid state, what do we call ionic solid state? Crystal. If it's in its crystal, do they move? No, they're locked into place. Okay? They would vibrate, yes, but they're not mobile. They can't move, right? So, when we pour it into water and it dissolves, does it become mobile? Yes, so the mobile and charged particles are present, the higher, first Friday of every month, 12, okay. The higher the concentration of the ions in the solution, the better the conduction. Is that exactly what we just said? Okay. The magnitude of the charge also matters. Now I know this sounds kind of weird. The magnitude of the charge. First of all, what does magnitude mean? The size, the amount, the value. So the size of the charge also matters. And let me explain what I'm talking about. What if you have Ca2 plus versus K plus? Which one has more of a magnitude of power? Ca2 plus, right? So you're going to get a little bit more off of the magnitude of the charge. Because for every 1 calcium, how many electrons did it throw away? 2. So you get 2 for every 1. So you have more electrons, right? Mason, you're first. Yes. Yeah. Okay. So charged and mobile is the key phrase. Okay. Ions must be in solution to conduct current. If there are no ions, it will not conduct solution. What is a non-electrolyte? A non-electrolyte is a substance whose aqueous solution does not conduct electric current. It does not produce charged particles, and some examples are sugars, alcohols, antifreeze, and starch. Okay. What is starch? It is a carbohydrate. But what is a carbohydrate? Well, duh. It's a sugar. Okay. There are 3 types of sugars. Actually, really. Simple and complex. But within those two, you have monosaccharides, disaccharides, and polysaccharides. Okay. Starches are complex sugars. They are polysaccharides. Okay. So you're right. They are found in potatoes. I'm not talking about the stuff that makes your pants stiff. Okay. So starch is a very complex compound. So let me ask you something. If it's a large, complex compound, what do you think the bond energy is within that compound? Very high. So is it easy or hard for our bodies to metabolize that starch? Very hard. Okay. So that's why if you eat a lot of starchy foods like potatoes and fries, that stuff sits and you get really round in your midsection like me. Okay. Now, the reason they tell you to eat carbs and if you're athletic is because they're also good for you in terms of burning energy. Because there's so much energy in it that it sustains you. It's not a quick burst of energy. It's a sustaining energy. Sir? It replenish. Well, essentially. I mean, not really. You're not. I mean, I guess. Your body needs electrolytes for it to kind of work. So, yeah. Yes. Okay. All right. I'm gonna hold off on this. I'm gonna do something real quick. But first, I'm gonna get her go.